Hey guys, I'm going to be talking to you about approximation and estimation. So those two words look like very close synonyms, but actually they have a quite distinct difference in mathematics. I'm going to show you the definition of each one individually, and I'll show you why they are different and how they are different. So first of all, approximation. It's a value given to a number which is close to but not equal to its true value. So it's like this. If I have 47.32931, and probably it's actually even longer than that, we can just approximate it to 47.3 if I ask you to round it to one decimal place. It's basically rounding or approximating a number so it's not too long, but it still has that value of the number. Which is after we get the answer like that, a value like that, we just round it to some particular measure, and then we're going to just kind of reduce it down. But it's still very, very close to its true value. Okay, so it doesn't really matter. These two are very much identical, aren't they? Estimation is a value which has been found by judgment or prediction instead of carrying out a more accurate measurement. It's like prediction or a judgment. Say for example, if I ask you, what's the measurement of your room? You wouldn't say, my room is 5 meters, 5.62598 meters long, wouldn't you? So you probably just say it's approximately, would say it's as an estimation, it's approximately say 5 meters, although it probably is like 5.6 meters. It's an approximation, but it's more of a very rough estimate. It's a more rough judgment and prediction. This doesn't represent a more accurate measurement. So usually approximation is more accurate. If the estimation is a little bit less accurate because it's by judgment and just by looking at it and just got a bit of estimation. So for example, if I say to estimate 39.5 times 4.1, now 39.5 is more closer to 40 and 4.1 is just estimated as 4, isn't it? So we just round it to whatever it's close to, another probably like a whole number that it's close to. We usually use whole numbers in estimation because we want to keep it rough and simple. 40 times 4 will be what we're going to be multiplying, and that will be 160. 160 is probably a lot different to 39.5 times 4.1, but it's not too different, but it does give you quite a rough estimation. Makes sense, guys? Those two terms are what we're going to be using. We're going to be using these to answer the questions. So make sure you understand the difference. Now, I'm going to talk to you about error using approximation and estimation. Whatever value you approximate or whatever value you estimate, depending on what the question asks you to do, whatever that is, we minus it away from the actual value. So the actual value of whatever you're calculating, you subtract it away from your approximation or estimation. That's the error. So it could be a negative number, right? If the actual value is bigger than your approximation or estimation. So it could be positive, it could be negative, but that's the error which gives you the difference between the two. Percentage error. So two terms you're going to know. The first one is error that I've just explained, and the second one is percentage error. So I want to know the proportion of that error in respect to the actual value. See how the error was how we calculated in the first part here? I'm going to put absolute values around it, absolute bars. For those who don't know what absolute bars is, it's just these two vertical lines around the number that always make the outcome positive. So say for example, if I have 2, it will just be 2 because 2 is a positive number, it's just positive. But if you have say -2, if it's inside the absolute bars, it will just turn to a positive number. So absolute bars magically just change negative numbers into positive numbers. Just remember that. Because I put that around because errors, as I said, can be negative. So that's why I'm putting absolute bars, just to make sure it's positive. We put that over the actual value. Make sure you always put it over the original value. And then you just multiply by 100 to get the percentage. So that's the percentage error. So if the percentage error is quite large, that means the difference between the two is quite large and is not a very good approximation or estimation. Even though we approximate or estimate, we still want the value to be quite close to the original value. We don't want it to be too distinct, right? So that's kind of how we distinguish whether it's an okay estimate or if it's too rough. So that's the two I want you to get familiar with. Let's do a quick example. An estimated value of a pipe is 60 meters, whereas its true length or actual length it's 61.2. So to get the error, I simply subtract the original value, the actual value or the true value, from the estimated value. So the estimated value is 60 and the original value is 61.2. Subtract it and you'll get negative 1.2. It's going to be a negative number because the actual one or the true one is bigger than the estimated one. We get negative 1.2. Now I want to find the percentage error, so I'm going to put it into this formula here. Make sure you put absolute bars around the negative number, yeah, because we always want it to be positive. So it's negative 1.2 absolute bars over the actual value. The actual value, the true length, is 61.2. We put that on the denominator and just multiply it by 100 and you should get 1.96%. Okay, so it's like a percentage. So it's not that bad, is it? 1.96 is a relatively small number. The approximation or the estimation isn't too bad. We can kind of make a judgment on that.